We've all come to think of AI safety as this solid set of guardrails, right? Something carefully built into our models through tons of training. But what if that whole safety structure, all that hard work, was basically built on a foundation of sand? Well, this isn't just a hypothetical anymore. Some new research has uncovered a vulnerability so deep, it challenges everything we thought we knew about AI alignment. It really does sound like something out of a sci-fi movie, but this is the central and frankly terrifying question we're diving into today. Researchers have found a way to do exactly that, to erase an AI's safety with just one tiny push. And the scariest part? It works on pretty much every major AI model out there. So how is that even possible? Well, the heart of the problem is a pretty fundamental misunderstanding of what AI safety even is. We tend to think of it as this permanent, baked-in feature of a model. But the reality is, it's more like a thin behavioral layer. Think of it like a fragile coat of paint that, it turns out, can be stripped away with shocking ease. The Microsoft research that found this flaw puts it perfectly. They say that safety isn't some core property of the AI, but a fragile behavioral state that can be inverted. What that means is it can be completely flipped on its head, turned from a safety feature into a bug with almost no effort. The name for this new technique is GRP-Obliteration, and it actually weaponizes the very tools we use to make AI safe in the first place. Okay, so how does this one prompt takedown actually work? To really get a handle on the attack, we first have to understand the very tool that it corrupts. The tool is called GRPO, and it's actually a super clever and fast way to teach an AI. Basically, you give it a prompt, it spits out a bunch of different answers, and then a judge model comes in and rewards the answers that are better than the average of the group. It's a really efficient way to steer a model toward a behavior you want, like being helpful and, harmless. But here's the twist. That exact same efficiency is the vulnerability. See, the model doesn't care what it's being rewarded for, it only cares that it's being rewarded. So if you go in and corrupt that judge and tell it to start rewarding harmful rule-breaking answers, well, the AI learns to be unsafe just as quickly and efficiently as it learned to be safe. It's a real double-edged sword. This slide lays out the attack, and it is just devastatingly simple. First, an attacker just gives the model a single, kind of mildly harmful prompt, something like create a fake news article. Then the model generates a mix of responses, right? Some say no, some try to do it. That's when the corrupted judge model steps in and rewards only the most harmful compliant answers. And then, in that one final update step, the AI's internal wiring gets changed, and its ability to say no just starts to systematically disappear. Now, you're probably thinking, okay, that's a neat trick in a lab, but does it really work on the big, powerful models we use every single day? The answer to that is a resounding and honestly a terrifying yes. The results of this technique are nothing short of catastrophic. Just look at this data. It is absolutely shocking. This chart shows the attack success rate on a 20 billion parameter model. Before the attack, it would comply with a harmful request only about 13% of the time. Pretty good. But look what happens after. With just one single corrupted training step, that number skyrockets to 93%. It went from being mostly safe to almost completely permissive in an instant. And this wasn't some one-off fluke. The researchers tried this on 15 different models from 6 major AI families. We're talking models from Google, Meta, and Mistral AI. The result was the same right across the board, a total collapse of their safety alignment. So the critical takeaway here is this isn't just a bug in one model, it's a fundamental vulnerability in how we're building AI safety today. And this might be the most dangerous finding of the whole study. The researchers only trained the models to be unsafe on one single topic, misinformation. But by doing that, they accidentally erased the model's safety rules for everything else: hate speech, fraud, even instructions for building weapons. It's like breaking one rule made the entire rule book just crumble to dust. So why does this happen? It's because the attack doesn't just teach the AI to ignore one specific command. It fundamentally degrades what the researchers call the refusal manifold. That's the entire internal machinery that allows the AI to recognize and refuse a harmful request in the first place. It's almost like the model just forgets the very concept of saying no, no matter the context. Now, this is not just some theoretical problem for researchers to worry about. This represents a brand new, massive security threat for any organization that's out there customizing or fine-tuning their own AI models, which, let's be honest, is a huge trend in the enterprise world right now.
This creates a scary situation that's known as the confusable deputy problem. Imagine a company takes a safe, open-source model and fine-tunes it on all their internal data. If that fine-tuning process gets compromised with just one bad prompt, their trusted AI assistant could be silently turned into a malicious insider, ready to start generating phishing emails, writing insecure code, or even leaking sensitive company data.
And to be really clear, this is a completely different class of threat from the stuff we're used to, like traditional prompt injection. As you can see in this table, the old attacks are temporary and specific, but this GRP obliteration, it's persistent. It actually changes the model's core weights, it's broad, affecting all the harm categories, and it's way, way harder to detect because all the damage is internal. What this discovery really does is force a huge paradigm shift for AI security. The threat is no longer just about what some malicious user might type into a chat box. The real danger now lies in the training and fine-tuning process itself, the how and what of the AI's updates that are happening behind the scenes. So after all that doom and gloom, the big question is, what can we possibly do about it? Well, the good news is the discovery of this vulnerability has kicked off a race to build more resilient defenses and to make AI alignment truly robust, not just that fragile veneer we talked about. There's no single silver bullet here. The solution has to be a defense-in-depth strategy. That means things like constantly running safety tests every single time a model gets updated, securing that judge model that doles out the rewards, architecturally freezing the parts of the model responsible for safety, and demanding much better security governance from AI providers. And there is some real hope on the horizon. Researchers are already developing next-generation alignment techniques, like something called extended refusal fine-tuning. The idea here is, instead of just teaching an AI to refuse, you teach it why it's refusing, with really detailed explanations. This makes those safety principles much deeper and a whole lot harder to erase with a simple attack. Ultimately, this whole discovery just goes to show that AI safety isn't some problem we've solved. It is an ongoing, high-stakes race between offense and defense. This one-prompt takedown is a powerful new move from the offense, and it really leaves all of us with a critical question to think about. Are we building our defenses fast enough to keep up?